Hello, my name is Fabian Corrales, and in this video we will be reviewing Chapters 6.1 and 6.2, the Modern Periodic Table and its Features. While watching this video, I recommend that you have out in front of you your own table so that as I explain, you can see for yourself firsthand what is being described. As your chapter outlines, we will be reviewing the development of the table, how it came to be, as well as its key features. We will also encounter new vocabulary such as atomic number that we will go over in later slides. The main idea, however, is that over time, scientists from around the world did extensive research and studying to compare and organize known elements. Some additional objectives that I have outlined here include learning about the origin and formation of the periodic table, learning the features of each element box and the table's uses, as well as to learn of the setup of the periodic table of elements based upon subsections and element characteristics. A French chemist by the name of Antoine Lavoisier assembled a table much like this one that shows simple substances. In his table he included gases, metals, nonmetals, and earths like chalk, magnesia, barote, and clay. He compiled a list of all simple substances and elements that were known at the time. The 1800s, however, brought large amounts of information and scientists needed a way to organize knowledge about elements. Now to go over the creators of the table, we have Dmitry Mendeleev, who was a Russian scientist who published one of the first ever periodic tables. He ordered elements according to their relative atomic masses. Next, we have another contributor of the table by the name of Lothar Meyer. He was a German scientist who worked alongside Dmitry Mendeleev to generate a table of elements that were ordered reasonably according to the extensive research that they did over their years of study. The last and one of the most important contributors of the periodic table of elements that I will mention is English physicist Henry Moseley, who worked to order the elements of the periodic table according to their proton count as opposed to their relative atomic masses. Scientists who studied the table throughout the century were concerned that Mendeleev's rendition was not optimal. Moseley's outcome eased their worries. Ultimately, it can be summarized that Mendeleev and Lothar Meyer analyzed a correlation between atomic mass and elemental properties, while Henry Moseley arranged the order of elements according to atomic number. This method of patterned order is referred to as periodic law. Meyer and Mendeleev both demonstrated a connection between atomic mass and elemental properties, while Moseley rearranged the table by increasing atomic number, which resulted in a clear periodic pattern. Now, to go over the structure of the periodic table of elements itself, we should first recognize that on a periodic table, columns are called groups, going downward, while horizontally, rows are called periods. To easily remember these terms, think that periods go at the end of a sentence, horizontally. It is also important to note that groups are numbered at the top of the table, starting from 1, where the alkali metals are, and ending at 18, where the noble gases are located. On a periodic table, each element box contains the element's atomic number, symbol, element name, and atomic mass. In this example here, we have lithium, which has an atomic number of 3, as shown in the top left. We have the symbol, which is located in the middle, Li, and we have the atomic mass, 6.941. The biggest portions of the periodic table itself are split into representative elements that are located on either side of the transition metals, which are located in the middle, and the bottom two lines are called inner transition metals. The wide array of elements are split into different groups based upon their properties and characteristics. We'll start with Group 1, the alkali metals. Group 1 does not include hydrogen. We'll talk about that later. Group 1 does include alkali metals of lithium through francium. All these elements here have one valence electron, and because of that are unstable and are very reactive. Group 2, the alkaline earth metals, include everything from beryllium to radium. These elements have two valence electrons and are also reactive, yet not as reactive as group 1. In between 3 through 12, we have transition metals. In column 16, group 16, we have chalcogens, which include elements like oxygen and sulfur, and others. These elements all have 6 valence electrons and are a very diverse group of elements because they're elements of different states of matter, as well as elements that are metals, nonmetals, and metalloids that run along the staircase. In group 17, we have halogens from fluorine to down here, and these elements have 7 valence electrons. Noble gases in group 18 include everything from helium to radium. These elements all fulfill the octet rule and thus are the most stable gases. On the bottom, we have the inner transition metals right here, and these two are split into the lanthanide series and the actinide series. Now we have properties of metals versus properties of nonmetals. Nonmetal elements are located on the right side of the table, while metals are located on the middle and left side of the periodic table. Metal elements are known to be shiny, good conductors of electricity and of heat. They are known to be malleable, ductile, as well as solid at room temperature. Nonmetals, on the other hand, are poor conductors of electricity, poor conductors of heat, dull, and they are brittle. Now there are a total of 7 known elements that are considered metalloids. They are located on the staircase of the periodic table, as shown in this picture. These 7 elements include boron from the top, silicon, germanium, arsenic, antimony, tellurium, and polonium. These elements contain characteristics of both metals and nonmetals, making them what are known as metalloids. Now we will review which elements are gas, liquid, and solid at room temperatures. So, this table that I have here has a key. Those elements that have solid black letters for symbols are solid. Those that are blue are liquid, and those that are red are gas. All the noble gases on the right side are red letters, thus are in gas form, as well as nitrogen, oxygen, fluorine, and chlorine. Then the 2 elements that are in liquid form are bromine and mercury. Hydrogen is also a gas, and if you want a rule of thumb, then you can recognize that on the left side, all the elements are typically solid form, while on the right side you have a mix of liquid, bromine, and mercury, and then on the top right you have mostly gases. One of the most important uses for the periodic table is forming electron configurations. When forming these configurations, it is important to note that the SPDF levels are located as such. The S level is inclusive of groups 1 and of groups 2. So this is S. Then the P level is inclusive of 13 here and 18, where the noble gases are. That is all P in here. Then we have, by the transition metals, this level is called D. And down here by the inner transition metals, by the lanthanide series and the actinide series, we have sublevel F. After having reviewed everything that we've done so far in this video, now it is time to test our knowledge and see what we can recall from what we learned. We will do 4 example problems. This first one we'll do together. The question is, given the following elements, identify the group names of each element location. So this is the small sublevel categories that we were talking about earlier. The first element that it asks us for is lithium. Lithium we see right here, and we know that this area here is called the alkali metals. Number 2 is mercury. Mercury we know is one of the liquid ones that's located right here within the group of transition metals. Number 3, beryllium. We know that beryllium is right here. This is the alkali earth metal. Chlorine over here is a halogen. And the last one, xenon, right here, is a noble gas. The next question that we go over will be a viewer question for you. So after I read the question out loud, you can please pause the video to answer independently. The question is, given the following elements, identify the letter sublevel, S, P, D, F, in which the outermost electron of each element is located. At this time, you can pause the video. So, to go over it, the first element that it gives us is magnesium. Magnesium is located right here, and we know this to be where S is located. We'll label them all. So this is S, over here is P, transition metal is D, and down here inner transition is F. So this one we know is S. The next one that it gives us is aluminum. Aluminum is located right here, and we know that this is in the P sublevel. The next element is cerium. That is located right here. That is in the inner transition metal group, and therefore it's in sublevel F. And the last element that it gives us is manganese, right here, and that is in the sublevel of D. For this next higher order question, it would be beneficial to you to pause the video when I am done reading the question. The question reads, element X has properties of both metals and nonmetals. Identify element X. The choices are A, boron, B, mercury, C, hydrogen, and D, bromine. You can pause the video. To go over this question, it is important to note that when it says properties of both metals and nonmetals, you should right away think of what we described as metalloids. Metalloids are located along the staircase here. A, boron, is located here. B, mercury, is located over here. C, hydrogen, and D, bromine. The only option that is located along the staircase is A, boron. For this last review question, to recall all the information that you learned in this video, it is important that you pause the video after I read the question aloud. The question is, by analyzing what you learned about the scientists Moseley and Mendeleev, the Russian scientists, and their work in having created the order of elements called periodic law, identify which two properties they related. You can pause the video. In order to explain this problem, I should first dictate all the answer choices. A is atomic weight, B, proton count, C, chemical and physical properties, and D, sublevel categorization. If you recall what we learned earlier in the video, When we learned about the history and formation development of the modern periodic table, you'll remember that Mendeleev and Moseley both related their two properties of A, atomic weight, and C, chemical and physical properties. Proton count was a different circumstance, and D doesn't have anything to do with this particular question. To fully go over everything that we've learned in this video, by watching this video you've learned about first the development of the modern periodic table and the scientists that contributed, like Mendeleev and Moseley. We also learned about the major features of the periodic table of elements, as well as some of its uses in chemistry. The major features included its sublevel categorizations and the different sublevels, and some of its uses in chemistry, like we spoke about, include Lewis dot structures as well as electron configurations. The last thing we learned was the structure of the table, the names of each major group, and some of the notable characteristics that go along with each group of elements. We compared and contrasted the nonmetals and metals. We talked about properties of each. We named each major group, representative elements, transition metals, intertransition metals, and we talked about the notable characteristics, groups, and periods. And finally, a big thank you to those who contributed to the sources used in our pictures and information, and thank you for listening to this video on the development of the modern periodic table.